In this video, let us have an introduction to conic sections or conics. First, let us see what is meant by conics. Here you can see a double napped cone. So here it's called a double napped cone. This is the vertex. Suppose you cut this cone by a plane which is perpendicular to the axis of this double napped cone. So you will get a circle. Circle. If you cut by a plane which is not perpendicular to the axis, it is in a slanted plane, so you will get to what is known as ellipse. Then if you cut this by a plane which is parallel to this side, so you will get what is known as parabola. So, parabola. Then if you cut along a plane which is parallel to the axis, so you will get what is known as hyperbola. Ellipse, parabola, then hyperbola. So since these are got from cutting this cone by different planes, these are all known as conics. Ellipse, parabola, hyperbola. So while learning physics, the concept of ellipse is very important. According to Kepler, planets are going in an elliptical orbit with Sun at one of the foci. Then many engineering branches idea of this shapes are very important. So let us see in detail about conic sections. First, let us see the definition for conics. Here there is a point, moving point. Then there is a fixed point and a line. Fixed point is called focus and the fixed line focus, and the fixed line is known as directrix. Then this is a moving point. Then definition for locus, conics. It is the locus of the point which moves such that its distance from a fixed point bears a constant ratio to its distance from a fixed line. That means SP by PM should be a constant. This is moving such that its distance from a fixed point bears a constant ratio to its distance from a fixed line. Then the path traced by this point is a conic. Then this constant is known as eccentricity. SP by PM is a constant. That constant is E. Now you square both sides. SP square, PM square, E square. Then rearrange. So you will get SP square is equal to E square, PM square. SP, this distance. So you can apply the distance formula. Then distance formula, SP is equal to square root of x minus x1 all square plus y minus y1 all square. Here it is sp square. So x minus x1 square plus y minus y1 all square is equal to e square. Then pm, this distance. Equation of the line is lx plus my plus n is equal to 0. Now here you can apply the distance formula, distance to a line from a point. So for this, distance is lx plus my plus n divided by square root of l square plus m square, l square plus m square. So this is the equation for finding the distance of a point from a line. Then it's square. Now if you square this term, there will be an x square term. Then here there is an x square, so you collect all the x square term. So it's a coefficient, we can give the name a. So ax square. Similarly, there will be y square. Then it will have a coefficient for that cy square. Then here there will be an xy term. When we square this, there will be an xy term. So it's a coefficient, you can give the name b. Then a x term. So when we square this, there will be an x term. Coefficient of x term, let it be d. Coefficient of y e, plus then a constant term. After squaring and rearranging, you will get a expression like this. So this is the general equation of a conic. Ax square plus bxy plus cy square plus dx plus ey plus f is equal to 0. Now b square minus 4ac, where b is the coefficient of xy term, minus 4ac. A is the coefficient of x square term, c is the coefficient of y square term. B square minus 4ac. After substituting the values, you will get b square minus 4ac as 4 into e square minus 1. Now for b square minus 4ac, there are three possibilities. If it is equal to 0, it will be a parabola. For this e, there are three possibilities. E can be equal to 0, 1, equal to 1. When b square minus 4ac is equal to 0, this is to be 0. If it is to be 0, e square should be 1. That means e should be 1. When e is 1, parabola. B square minus 4ac is lesser than 0. If it is to be lesser than 0, b square minus 4ac is 4 into e square minus 1. If this is to be lesser than 0, e should be lesser than 1 and greater than 0. E should be greater than 0 but lesser than 1. Then it will be a ellipse. When eccentricity is lesser than 1, it is an ellipse. B square minus 4ac is greater than 0. If b square minus 4ac is to be greater than 0, e should be greater than 1. If e is greater than 1, it is known as hyperbola. So this is the general equation of a conic. So thank you for watching.